The module Vehicles provides facilities of widespread interest for companies that have vehicles, and so it shall be presented first. The facilities linked to the tracking of vehicles with geographical integration in Google, as they are designed to more specific situations, will be presented in a separate chapter. Now let's move on to the introduction of the general facilities and architecture of this module.
Organizations which have fleet need this module, particularly for the characterization of the fleet, contracts associated with it, interventions and attributions, mileage kilometer control, general consumptions, and expenses. The acquisition of services and products for vehicles is performed by the purchasing department, according to the facilities of this module and based on contracts and documents, though integrated with the management of vehicle. Should the module fixed assets be implemented, many data from fixed assets will be automatically inherited by the module vehicles. Regarding tracking and travels, these are facilities of the module 325, extension to tracking and travels. Only tracking is discussed in this video. The management of vehicle is integrated with the module fixed assets. The following elements are highlighted: the registration of vehicles, including accessories and documentation, contracts in general, insurance contracts and insured values, interventions and events, mileage kilometers and consumptions, general expenses.
Let's briefly consider the base menu of this module.
The menu of vehicles is divided into 4 areas. Are the options to set parameterization codes and others, as well as the options to set the typology of the products related to vehicles. In the middle are the options for the registration of vehicles, interventions, events, and consumption, and also the part related to insurance claims. Is a link to the extension to tracking and travel. In fact, this is a link to the module 325, tracking and travel extension, of which only the part regarding tracking via GPS and Google Maps shall be addressed in this video, without much depth though.
The correct registration of vehicles, especially if they are in great number and varied, demands some preparation in terms of the typological framework and products.
It's possible to establish a typological organization of vehicles in order to comply with a typological code in tree format. This kind of organization makes it easier on researching vehicles available with some given characteristics when there is a great variety of vehicles, including the ones of industrial nature, such as cranes, forklifts, tractors, graders, etc.
It's important to bear in mind that in our solutions, the vehicle is also seen as a product, integrated into the architecture of the subsystem of products and resources. As we shall see, the code of the vehicle itself consists of 2 parts. One is the product code and the other one is its identification number. Now let's look at the options for the definition of typology and products.
In terms of classes of products, we have defined in this case only one class for vehicles, the class V. As mentioned before, the vehicles are integrated into the architecture of products and resources, in this case under the class V. However, we could also split vehicles into several classes. In terms of types of products, we have chosen to define only one class, carrying out the typological subdivision of vehicles in types of products. We see here vehicles broken down into cargo vehicles, VC type, passenger vehicles, VP type, and other groups. Then, each group is further subdivided. For instance, cargo vehicles are subdivided into couple vehicles, light vehicles, heavy vehicles, and trailers. Let's consider this other option. The setting of specific attributes, in addition to the standard ones already defined in the application, is essential to properly characterize and register vehicles. These attributes are defined for each type of vehicle. For instance, attributes related to the anti-theft devices, air conditioning system, security, driving systems, among others, have been defined for the VPL light passenger vehicles. Now we can see the setting of product codes themselves. Each type of product could comprise multiple product codes. That's what usually happens in general in the architecture of products. However, taking a small organization into consideration, only one product code can be defined for each type. This is what has been done in the following example. As we shall see, the vehicle code shall consist of these product codes plus a number. For example, VPL 012.
As for the record of vehicles, there is the registration of the vehicle itself in terms of, for example,
license plate, make and model, category, type of fuel, color, engine capacity, number, gross weight, and tear, acquisition date, acquisition value, book value, and inventory number. Under this option, we get the list of vehicles including the most relevant information about them. Some information is encoded to spare space, but in the case of forgetting what some codes mean, just place the mouse cursor over them and the interface allows us to check their meanings. In this sample, PS stands for passengers and GA stands for gasoline. With a double click, we can access information to be changed if needed. It's possible through this item to control eventual maintenance to be done in vehicles or even for history purposes. Another important option for record purposes is the registration of the maintenance norms to be applied to each vehicle. An equally important element is vehicle insurances. In here, it's possible to manage insurances not only in terms of values, but also in terms of coverage and due dates.
Finally, in case the module fixed assets has been implemented, then vehicles also present data to be recorded in terms of fixed assets, mainly for tax, legal, and accounting purposes. We can see such data by accessing the option Fixed Assets items.
Let's move on now to the listing. The application treats fixed assets with relevant and obligatory information.
As far as vehicles are concerned, all events deemed important for the management of vehicles will be recorded under the generic name of interventions. Any type of events can be recorded, namely
batteries, refueling, inspections, washes, other interventions, exchange of tires, and overhauling.
This information allows an accurate cost analysis and timely decision-making in terms of management of vehicles.
The list of interventions is obtained under this option. According to the regular interface facilities, we can access information, change it, or insert new interventions. Based on the data from interventions, this application allows the control of consumptions in connection with kilometers, mileage readings. The system generates several types of consumption per vehicle every 100 kilometers miles. Another type of control is the total expenditure per vehicle over a certain period of time. Such expenditures are presented in total and broken down into types such as fuel, cleaning, overhauling, tires, etc.
Having a tool for registering information on insurance claims of vehicles is an important facility to go along with the recent claims or even for history purposes. Linked to claims are obviously insurance values, excess insurances, policies. The options related to insurance and insurance claims themselves shall be introduced as follows.
Under this option, we obtain a list of insured values on which policies, insured values, premiums, and excess insurances are broken down. Regarding claims, the elements recorded have to do with the vehicle, the third parties involved, and the claim itself.
The aforementioned facilities are enough to manage the vehicles or fleet of most companies, public service bodies, and other organizations. However, there has been an increasing number of cases in which tracking facilities are needed. Knowing where vehicles are, their routes, both in real time and historical terms, are often requirements. Moreover, the geographical location of facilities provided by Google are increasingly comprehensive and unique. We have combined in our solution tracking devices that systematically send out the position coordinates of the vehicle, as well as additional data with the facilities provided by Google, so the geographic location of vehicles and their routes can be viewed through Google Tools. Let's move on now to a brief presentation of such a facility.
The tracking of vehicles, equipment, and other assets starts with the installation of a tracking device like this one in the vehicle, equipment, or asset. This device is like a mobile phone equipped with GPS that periodically sends messages, communicating with our applications the coordinates of its position, direction, speed, and other data. Our modules receive those messages, record them in the database, and, as we shall see later, indicate on Google the current position, speed, and direction, the route traveled recently or some time back by consulting the history. These messages also enable other features, such as checking if schedules are being met, adjustments on travel times, and stop times. In addition to these messages being sent from the device to our applications, the opposite also holds true, that is, transmitting messages from our applications to the device and thus enabling sensors, providing instructions to the driver, and so on. In the presentation that follows, we will first illustrate the facilities related to the messages sent from the device to the headquarters, and then the ones related to the messages sent from the headquarters to the devices. The first step is registering the equipment. We see in this listing the pieces of equipment already registered. All configurations and specificities of each device are centered in here, which may vary according to the characteristics of the model and manufacturer. It's important to point out the connection of the device with a vehicle, piece of equipment, facility, or asset. Moreover, the parameterizations are defined so as to allow the communication between the piece of equipment and our application. For example, data from the telephone company, IP and server port, the setting of update time, in which the position is updated every minute, the SOS number, used to send out alerts, the location of the installation of the device, which are strategic points and vary from vehicle to vehicle of a fleet, and in here the connection of the device with the vehicle. The data sent from the devices are stored and processed in the item tracking positions. On the criteria panel, we can filter data in terms of history or real-time data and even vehicles or travels. The data on the list are assorted by vehicle, date and time, followed by latitude, longitude, and speed. The location of the vehicle is calculated over the coordinates of latitude and longitude. To view the vehicle on the map, just select Align and run the command Position on Map. Placing the mouse cursor on the point, we get basic information on the vehicle. By clicking on it, we have access to details such as the image of the car, date and time, speed. In this case, the car is parked. I can still use some of the Google Maps features, such as viewing the image by using the satellite view mode and even zoom it. If we wish to see the route of the vehicle, just select several rows and run the same command, Position on Map. Note that the points on this map are the lines I have selected, forming a route shown in blue. The point A indicates where the route starts, and the end is in red. We see more information by clicking on End. There is still the option to view the position of the fleet in the last 3, 10, 30, and 60 minutes. For instance, let's display the position of the fleet in the last 3 minutes. We see the positions of the fleet in the last 3 minutes. There are 2 cars in this case. It's worth recalling that the map updates the positions every minute. Another command is the travel map. If the route comprises only one trip, this command generates the map according to the data collected. Another way to view the real-time position of the car is going to the item Vehicles. Just select the vehicle and run the command Current Position on Map. It's possible to send instruction commands from our application depending on the specifications and resources of each device. Let's see it. Let's run the command alarm router on. This command triggers an audible warning useful in case of theft. The device automatically sends an SMS to the number configured as SOS number, which usually belongs to the party in charge of the fleet. Another practical example is fuel cutoff. Note that this type of command could be used for other purposes, such as locking doors or the box of a truck. And in the presentation on the facilities of the module Vehicles, we can see that the menu offers the options Courses and Travels. These are options used to deal with situations in which there are courses, routes established for vehicles, and travel within those courses, routes we want to manage. This issue will be deepened in our modules related to transport of cargo and passengers, so we leave the presentation of these facilities up to their respective videos.
We have presented in this video the module Management of Vehicles, along with the necessary detail for a first assessment by your organization. It should be stressed that, according to the organization at issue, we may be facing simple projects to be started immediately, or complex projects that include a variety of vehicles, and finally the tracking of vehicles geographically integrated with Google. Thus, this dialogue may be deepened, aiming at a better analysis of your needs and the answers we have to them. We and the network of partners we integrate are fully prepared to listen to and support you.